So, as we mentioned before, esterification reaction is a slow reaction and it requires heating. And in this case, heating in an open flask cause the alcohol and the carboxylic acid to vaporize, because carboxylic acid and alcohol are organic compounds which are volatile, which means that they evaporate or change into the gaseous state at low temperatures. While preparing esterification reaction, heat is necessary, and sometimes it can reach 60, 70, 80 degrees Celsius, which may cause one of the components or even both components, main components in this esterification reaction, to escape from the reaction mixture, which are alcohol and carboxylic acid. In addition to that, the ester formed, may escape because it is volatile. Again, volatile substance is a substance that change into the gaseous state, or it's change to its gaseous form at low temperature. Now it's the corona season and you are using alcohol as a disinfectant. You put alcohol on your hands, but it doesn't last for just a few seconds. Okay, why? Because it directly evaporate at your hands temperature. Okay, so we cannot prepare esterification reaction in an open flask and use heat at the same time. The components may escape from the reaction mixture. No more efficient contact between these two reactants, which are alcohol and carboxylic acid. Some of the ester may escape. All of these factors will decrease the yield of esterification. So, how can we solve this problem? Simply, we use something known as reflux heating. What is reflux heating? In reflux heating, we use the following setup. Simply, it's somehow similar to the distillation you used in grade 7. Okay, we use a round bottomed flask, heating mantle. Inside this flask we have the main components, the main reactants, alcohol and carboxylic acid, which are going to be heated for a period of time. We have a condenser placed on the top of the flask. This condenser made up of two tubes, the inner tube where the gases can pass through this inner tube, and the outer tube, which is blue in color, where water comes from this inlet and circulate around the inner tube to cool the gases escaping while heating. So if we start heating the mixture, some of alcohol, carboxylic acid or ester starts to evaporate or pass or escape from this mixture, moving where? Moving in this inner tube. When they reach this part, the water coming from outside, which is cold water, it's tap water, it cools the mixture, it condenses the vapors back to the reaction mixture so that none of the components will be lost. The gases will never reach the top. They cannot reach the top because this part, is cooler than this part. The condenser should not be sealed or closed from the top, not to avoid vapor pressure. Okay, so this setup you should know clearly. Always water comes from the lower part to cool the gases from the lower part, not from the upper part. So the water circulates, it's cold, it is cold compared to the temperature of the gases inside. So it circulates around this inner tube, cooling the gases escaping or trying to escape and returning them back to the reaction mixture, so none of them is lost. And in this case, we will require the yield expected. So in this setup or this type of heating is used in reactions which are already slow, such as esterification reaction, and I hope we will return back soon to school in order to prepare simply this reflux heating in the lab, and طبعا we will do saponification reactions. So what is the importance of this flask? This flask is used in order to heat the mixtures for a long period of time, okay, and not to allow the components of the reaction mixture to be lost, okay, so that the yield needed will not be affected.